that is more popular than rejection region approach that we are going to discuss today. That approach is called the p-value approach. And keep in mind both of these approaches all the time, they will give you the same decision as long as your alpha is same for both approaches. So today we are going to discuss the p-value approach. So for these three cases, the p-value is calculated as, the decision rule by the way is reject H0 if p-value is smaller than alpha, where p-value is equal to what? For case number 1, when your H1 is two-sided, the p-value is 2 times probability of z greater than z0 absolute value. For the lower sided, it is simply probability of z less than z0. And for the upper sided, it is simply probability of z greater than z0. This whole thing is called p-value approach. That is, you'll have the question, you will calculate the p-value from that statistic, and then finally once the p-value is calculated, and keep in mind when you are calculating p-value, it does not involve alpha. In these p-value expressions, you will not see alpha anywhere. The calculation of p-value does not involve alpha, but once the value of p-value is calculated, then you compare it with alpha. If it is less than alpha, you reject H0. If it is more than alpha, you fail to reject H0. This whole approach is called p-value approach. And then there is third approach that we have already discussed in chapter 8. That approach is confidence interval approach. And in this approach, what we do is we create the confidence interval and we reject H0 if X bar does not belong to the calculated confidence interval. That is, you will create the confidence interval X bar plus minus 2 times, not 2 times, Z alpha by 2 times sigma over root of n. And if X bar belongs to this interval, if not X bar, mu naught. If mu naught is within this interval, you will fail to reject H0, but if it is outside the interval, you will reject H0. And if you remember in chapter 8, we never talked about one-sided hypothesis. So I'm putting a cross here. These cases are not with you. One-sided confidence intervals, they do not belong to the syllabus of 319. These are the three approaches of testing any hypothesis. You can test a hypothesis using the rejection region approach, or using the p-value approach, or using the confidence interval approach. Let me pick the question that we were solving today, and I'll solve the same question with all three approaches. This was the question we were solving. And in this question, if you remember, our Z value was 2.5044, and for 95% alpha 5%, your critical value was 1.645. Let me write it down. Let me pick a two-sided question so that we can compare all three approaches. Suppose we want to test that the average of Stat 319 mid-exam is 60%. Or let me say in absolute words, it's 12 out of 20. This is what you want to test. A random sample of, let us say, 25 students gave a mean of let us say 11.1. Test the relevant hypothesis assuming population standard deviation to be 0.5 and alpha to be let us say 0.05. This is the question we have. We have to test that the population average of midterm exam is 12. So first we read the question, write down the question in terms of the statement. So we want to test that the average of Stat 319 midterm exam, that is 12. So I'm going to write the question in terms of notation, that is mu equals 12. That is my claim or question. Then I will write the opposite. What is the opposite? Mu is not 12. Mu is not 12. Then I will see which one has equal sign, which one does not have equal sign. So the first one has equal sign, I'll call it H0. The second one does not have an equal sign, I'll call it H1. Once H0, H1 is there, I'll extract the data. So for the data, I have n equals 25. I have x bar equals 11.1. And I have sigma equals half. So I'll calculate the value of z from here. The value of z will be x bar minus mu naught divided by sigma over root of n. 11.1 minus 12 divided by half over root of 25. That will give me 11.1 minus 12 over 0.5. So that will give me minus 9.
Yes.
Minus 9. So let us use the rejection region approach. Number one, if you use the rejection region approach, you will say reject H0 if Z naught absolute is more than Z alpha by 2, where this Z alpha by 2, which is actually Z 0.025 if your alpha is 5%. From the table, it comes out to be 1.645. I'll not go into the details how I got this from the table. We did this in the last class. So you will say as Z naught absolute, which is 9, it is more than 1.645. So we reject H naught and conclude that mu is not 12. The average score is not 12. That is the first approach. Let us use the second approach, p-value approach. And keep in mind, in exam, we are going to ask you only one approach in one question. If you are using the p-value approach, you will calculate the p-value first, and the p-value is 2 times, for a two-sided hypothesis, it is 2 times the probability of z more than z naught absolute. So you put the value of z naught, it is 2 times probability of z more than -9 absolute. This is going to be 2 times probability of z more than 9. Now z table is not available in more than form, it is available in less than form. So you'll convert to less than, so it will be 2 times 1 minus probability of z less than 9. Now who can tell me what is the probability of z less than 9 without looking into the z table?
0.
It is 1. Less than 9, everything.
Yes.
Greater than 9 is 0. For greater than 9, you are right, it is 0. So less than 9 is 1. So 1 minus 1 is 0, and 2 times 0 is almost 0. So p-value is almost 0. And you can see in whole calculation of p-value, I did not involve alpha. Keep in mind, when calculating p-value, you don't need alpha. Once p-value is calculated, now you compare it with alpha. So compare it with alpha. You will say as p-value is less than alpha, so we reject H0. And conclude that same. The midterm average is not 12. Muhammad Faris.
Yes, Doctor. Why you said b value almost 0, not equal?
Because the probability of z less than 9 is almost 1, not exactly 1.
Oh, okay. Thank you.
So let's talk about the third approach, the confidence interval approach. In this approach, I will simply create the confidence interval. And then if my mu naught falls inside the interval, I will accept H0, otherwise I will reject H0. So let us create the confidence interval. That confidence interval is x bar plus minus z alpha by 2 times sigma over root of n. So that will be 11.1 plus minus 1.645 times 0.5 over root of 25. So my confidence interval, this is basically a 95%, by the way. Is it 95%? No, sorry. Wait. For alpha by 2, I'm using the wrong value. It's 1.96. 1.645 is one-sided. Your hypothesis is two-sided. Okay, so it should be 1.96. 1.96 times this one. So what is the confidence interval? 11.1
Equal, Doctor, 0.196. Without the minus or plus. The left side. Sorry, the right side. Equal 0.196.
Okay, what is the lower limit?
Lower limit 10.0 no 10.904.
What is the upper limit?
Limit yes, same as you wrote.
Okay, So your conclusion will be, you will say as 12 does not belong to this interval. You're testing mu equals 12, by the way, here. I'll write it. You're testing mu equals 12 against mu not equals 12. So your conclusion will be as 12 does not belong to this interval. It's not inside the interval. So we reject H0 and conclude the same. So here you have all the three approaches on a single question. As long as you use alpha same for three approaches, you'll get the same decision, same conclusion. Ali Abdul Rauf.
Yes, doctor. Is it specified in the question which approach should I use, or I can use either one of them?
If there is no specification in the question, you can use any of them. But if the question specifies, then you will be stick with one of them. For example, we can ask you the question that blah, 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 find the p-value of the test. We can ask you this, find the critical value.
Oh, so I need 3 of them. Okay. Thank you.
Any other question? Okay, in case there is no question, let us move on to the case, the second case. Exactly the same thing. I'll copy whole this thing. But the second case is when sigma is unknown. And if you remember from chapter 8, when sigma is unknown, what do we do? Instead of Z, we use what?
T. If
We
we
use
don't have sigma.
We use T. So everything in the table where you see Z, it will be replaced by T. So here we have testing hypothesis about mu when sigma is unknown. You'll be asked to test same 3 types of hypothesis: mu equals to something against not equal to something, bigger than equal to something against less than something, or less than equal to something against bigger than something. Your test statistic this time will be T, and your sigma will be replaced by S. And the degree of freedom V will be n-1. You will reject H0 if T0 is more than T alpha by 2 with V degrees of freedom. T0 is less than minus T alpha with V degrees of freedom. T0 is more than T alpha with V degrees of freedom. So everywhere I replaced Z by T. Also in the p-value, I replaced everything by T. And also in the confidence interval, I'll replace it by T alpha by 2 with V degrees of freedom and sigma by S. So this is the whole map, whole thing about testing hypothesis when sigma is unknown. Let us try to solve the same question but this time assuming sigma is unknown. So I'll copy the same question Same question, but this time I'll change the question slightly and I'll test the relevant hypothesis assuming alpha to be 5%. And with the sampled information, a random sample of 25 students gave a sample mean of 11 and a standard deviation of, let us say, 0.6. So this is now sample standard deviation, not the population standard deviation. So again, let's do the one-sided hypothesis now. Suppose that we want to test that the average of STAT 319 midterm exam is more than, or let us say this, I'll change this one also, is more than 12. More than 12. A random sample of 25 students gave a mean of, let us say, 11.5 and a standard deviation of 0.6. Okay, so let us read the question and make H0 H1 like we make it. Suppose we want to test the average of STAT 319 exam is more than 12. So your claim in the question is mu more than 12. That's the claim. That's the question. Write down the opposite. The opposite is mu less than equal to 12. So the one that contains equal sign, that is your H0. The one without equal sign, that is your H1. Once you make H0 H1, gather the sampled information. You have n equals 25. X bar equals 11.5 and sample standard deviation equals 0.6. Once you have the sample information, calculate the test statistic T. So your T statistic will be X bar minus mu naught divided by S over root of n. And that will be 11.5 minus 12 over let me change this 12 also. Let's make it 11. We want to test that mu is more than 11 to make it a more practical question so that the test statistic is positive. 11 over 0.6 divided by root of 25. So that will be what? That will be
4.1667.
4.1667. And your V here is n minus 1, which is 24. Now, if you look at the rejection region approach, the approach goes as follows. You will reject H0 if, look at H1, H1 is greater than, so your rejection region will also be greater than. If T0 is greater than T alpha with V degrees of freedom. And for your critical value T alpha, your T 0.05 with 24 degrees of freedom, you will go to the T table. And I believe we have the T table somewhere in this chapter 8. Here we have this T table. And you will go to the T table with 24 degrees of freedom. So I'm going to highlight 24 degrees of freedom row. 24, this is too big. I'm going to highlight the 24 degrees of freedom and alpha 0.05. So the value is 1.7109. Because the hypothesis is one-sided, I will not divide alpha by 2. Because my H1 is one-sided, I'm looking for alpha directly and not alpha by 2. I'm looking for 0.05 or I'm looking for 0.95 if you talk about the lower tail area. So this time I will not divide alpha by 2. So my value is 1.7109. So the critical value comes out to be 1.7109. So I will reject H0 if my T0, which came out to be 4 point something, if it is greater than 1.7109. So I will say as my T0 is more than 1.7109. So we reject H0 and conclude that the average is more than 12. 11, sorry. We were testing 11. The average is more than 11. That is the rejection region approach. Let's talk about the p-value approach. For the p-value approach, you need to calculate the p-value, and that will be, keep in mind your H0 is mu less than equal to 11 and your H1 is mu more than 11. So p-value expression comes from the sign of H1. Sign of H1 is greater than. So p-value will be probability of T with 24 degrees of freedom greater than 4.1667. Probability of T24 greater than 4.1667. So you'll go to the T table and look for the probability in T24 degrees of freedom more than 4.1667. So let me copy this thing and go to the T table. This is what we want. This is what we want. T more than 4.1667, and we will not get it exactly from the table because T table is not very comprehensive. Now, here is the trick. Look at the T table. You are concerned with 24 degrees of freedom. So this row is where you will look. Your answer is in this row. Now, unlike Z table, not all the values of alpha are available here. There are only a few, like 1, 2, 3, 4, 5, 6 values of alpha available. Only 6 probabilities are available. There is 0.005, 0.01, 0.025, 0.05, 0.1, and 0.25. That's it. Only 6 values are available. Unlike Z table, there are many values available, all the way from 0 to 1. Most of the values are available up to 4 decimal points. Here we don't have all the values available. So what's the trick? We will have the p-value in terms of an interval, not the exact value. We will not get the p-value as an exact value. We'll have the p-value as an interval. To get that one, I will try to tell you the meaning of one of these values. For example, 1.7109 in this row. What does this mean? This means that the probability in T24 degrees of freedom more than 1.7109, this probability is 0.05. The area above 1.7109 is 0.05. Similarly, the below area will be 0.95. Let's interpret another value. This one was this 1.71 something. Let's interpret another value. Let us say the last value. The probability in T24 degrees of freedom greater than 2.7969. This probability is 0.005. You are looking for this. You are looking for probability of T24 more than 4.1667. Is 4.1667 available in this row? The answer will always be no. The answer will always be no. But there will be a value which is below 4.166 that is available and or bigger than 4.1667 available. So look where 4.1667 falls. Where does it fall? Is it between the two values or it's to the extreme of right?
Extreme of right.
It's right extreme. It can be between the values, it can be on the extreme right, it can be on the extreme left. So it is on the extreme right. I will write it here. The T distribution is also a symmetric distribution. It is like this. The center of the T distribution is 0. Let us assume this is T distribution with 24 degrees of freedom. Now from the T table, we see that the last available value is 2.79. What was it? 2.7969. And the area above this value is this area above the 2.7969. This area is 0.005. Now your value is 4.1667. That is even further to the right. Even further to the right, 4.1667. And you want greater than area. Same right side area. So this area will be even smaller than 0.005 because it's even a small portion of 0.005. So you will say that this p-value, which is probability of T24 more than 4.1667, this is even smaller than 0.005. That's all you can say. You cannot give the exact p-value here in this case. You will say that the p-value is very small. How small? It is less than 0.005. Now, whatever it is less than 0.005. What is your alpha? Alpha is 5%. Now compare the p-value with alpha. Is it less than alpha?
Yes.
Yes, because p-value is something that is less than 0.005 and everything less than 0.005 that will be less than 0.05. So you will say as p-value is less than 0.05. So we reject its node. Same conclusion. The average is more than 11. Muhammad Faris.
Yes, doctor. I don't understand why when T24 greater than 4.1667 less than 0.005. In the graph it is greater.
In the graph?
Yes, this graph.
In the graph, it's greater than area. This greater than area.
So it should why it is less than 0.005? It is
Let
in
me
the area or the interval?
No, the answer, we're talking about the answer. We're not talking about the direction. There is one thing that is called direction of the probability. You are interested in the upper tail direction. This greater than sign, that means you are interested in upper tail. Okay?
So the area mean?
On the right side, not the area, not the magnitude of the area. We're talking about right side. This greater than means you are interested in the right side. That's one thing. Then if you look at the two areas on the right side, there is one yellow area on the right side and there is one green area on the right side. Which one is bigger?
The yellow.
Yellow one is bigger. So we will say that the green one is even smaller than yellow. So the green one is smaller than 0.005. Yellow is 0.005.
Yes, I understand. Thank you.
Both of them are bigger. So we're interested in bigger, but the green one is smaller than the bigger one.
It's okay.
Let us try to solve quickly a lower-sided hypothesis question, just for the practice. Test the hypothesis that population average is less than 12 with the same data. So here your H0, H1, that will be mu less than 12, that's claim. And mu more than equal to 12, that's the opposite. Then your T0 will be x bar minus mu naught over S over root of n, 11.6 minus 12 divided by 0.6 over root of 25. That will be what?
Minus 3.333.
Minus 3.333. If you follow the rejection region approach, you will reject H0 if T with 24 degrees of freedom, if T naught is less than minus T alpha with V degrees of freedom, where T with the alpha 0.05 and degrees of freedom 24, we'll go to the T table and look for 0.05 as the upper tail area and 24 degrees of freedom. So we'll go to the 24 degrees of freedom with upper tail area 0.05. It's 1.7109, exactly what we got previously. So we have this 1.7109. So you will be rejecting H0 if T0 is less than minus 1.7109. But you see, as T0 is actually less than minus 1.7109. It is minus 3.333. So we reject H0 and conclude that average is less than 12. P-value approach. For the p-value approach, your p-value will be probability of T distribution 24 degrees of freedom. This is less than minus 3.333. Now here there is something interesting. If you look at the T table is not available for the negative side. All the values in T table, you will see all of them are positive. Look at inside the table, all the values are positive. T table is not available for the left side. It is only the right half of the distribution is available. We don't have the left half of the distribution. So what's the solution? The solution lies in the fact that T distribution is a symmetric distribution. It is a symmetric distribution. And for the symmetric distribution, the left side is the mirror image of the right side. So you have to convert every question to the positive side first and then look into the table. How can I convert this thing into positive? I have to convert this thing into positive looking at the symmetry of the distribution. Here is T distribution, which is symmetric. The center of the T distribution is always 0. Now minus 3 point something is here. And plus 3 point something will be here. You are interested in less than minus 3 point something, which will be exactly the same as more than 3.333 because of the symmetry of the distribution. So you can write that this probability of T less than minus 3 point something is equal to probability of T24 more than 3 point something. Now this value you can go and look into the table. And let me change the information a little bit so that my value comes in between the two. This again is falling to the right extreme. I don't want it to fall to the right extreme. Okay, I'll solve another question after this one. So let's go to the T table and look for T distribution with 24 degrees of freedom. We go to the T table with 24 degrees of freedom and try to find 3.333333. And we don't have 3.3333. So we'll see where is 3.3333. It is somewhere here to the right. So the greater than area, look at the pattern, will be where? Will be in this rightwards direction, moving from 0.025, 0.01 and 0.005, and then the greater than area will be to the right of these values, and the right of these values is even smaller than 0.005. So this is even less than 0.005. P value is less than 0.005. Again, you will reject H0. Let's try to solve a two-sided hypothesis where I will try to make the value in between two of them. So let us say you want to test H0 that mu is 12 against H1 that mu is not 12. Let's say your n is 20. Let us say your x bar is your s is 1. And your x bar is 12.3, let us say. Okay, so let us try and solve this question here. So the first thing you will do is you will find T statistic, which is x bar minus mu naught divided by s over root of n. That will be 12.3 minus 12 over 1 over square root of 20. This will give you what?
One 1.3416.
1.3416. Now, if you want to use the rejection region approach, you will write reject H0 if my T0 is more than absolute value is more than T alpha by 2 with V degrees of freedom, where this T alpha by 2 with V degrees of freedom, if your alpha is 5%, your T 0.025 with 19 degrees of freedom, T 0.025 I divided it by 2 because I have H1 that is two-sided. I'll go to the table and look in 19 degrees of freedom this time. Look into 19 degrees of freedom. Against 0.025, it will be this value, 2.0930, 2.0930, 2.0930. That's my critical value. So you see my calculated value is 1.3416. You will see as T0 absolute is not greater than 2.093. So we fail to reject H0. And conclude that the average is around 12. It is not different from 12. That's the rejection region approach. What if we want to use the critical value approach? The p-value approach. So that will be p-value. It is 2 times probability of T24 more than what was it? 3416. Not 24, sorry. This question we have T 19 degrees of freedom. So first thing you will get this part from the table and then you will multiply it by 2. The first thing you need to do is you need to get this part from the table. And to get this part from the table, you need to see 1.3416 in the table. Let us try to find 1.3416 in the table. And obviously you will not find 1.3416 in the table, but you will find a value smaller than that and you will find a value bigger than that. So what is the value? Where is 1.3416 falling? It's falling in between two values. Which two values?
0.1 and 0.05.
0.1 and 0.05. It's falling in between these two values. So the upper tail probability will be in between 0.05 and 0.01. So what you will do is you will write this fact that the probability of T19 more than 1.3416, this is between 0.05 and 0.1, but this is not the p-value. P-value is 2 times this probability. So the p-value is you multiply this inequality 2 times all the way and you will get what? 0.1 less than 2 times probability of T19 more than 1.3416, 0.2. So your p-value is basically between 0.1 and 0.2. This implies p-value is between 0.1 and 0.2. We cannot give the exact because of the limitation of the t-table. So whatever this p-value is, if you compare it with alpha, assuming alpha is 5%, if you compare this p-value with alpha, anything between 0.1 and 0.2 is obviously more than alpha. So you will say as p-value is not less than alpha, so we fail to reject H0. So what's the deal? The deal is you have to convert every question of T distribution into bigger than, because the T table is available in bigger than form. And you have to convert every question of Z into less than, because Z table is available in less than form. Any question until this point? In case there is no question, let us move on to the next small topic we have. Testing of population proportion. If you remember, we made the confidence interval for P also. That was P hat plus minus Z alpha by 2 times P hat into 1 minus P hat over square root of n. So we can also test the hypothesis regarding population proportion. You will have 3 different types of questions we can ask you. We can ask you a two-sided hypothesis that P is equal to P naught against P is not equal to P naught. Or we can ask you P more than equal to P naught against P less than P naught. Or we can ask you P less than equal to P naught against P more than P naught. Same 3 types of hypotheses you may encounter for the population proportion. Now we have a different parameter P, not mu. Alpha will either be given or assumed 0.05. The test statistic we will use always be Z. That is going to be P hat minus P naught over P naught into 1 minus P naught over n whole square root. Once you have the value of z, the rejection region, the p-value, they are all similar to z, the one we discussed for mu, they are all similar. So the rejection region approach will be reject H naught if for the two-sided it is z naught absolute is greater than z alpha by 2, z naught is less than minus z alpha, z naught is more than z alpha. The same we used for mu. And the p-value will also be same. P-value will be 2 times probability of z more than z naught absolute, probability of z less than z naught, and probability of z more than z naught. And the confidence interval we created for two-sided, that was p hat plus minus z alpha by 2 times p hat into 1 minus p hat over n square root. We did not create any confidence interval for one-sided. This is all we have from proportion. All the three approaches. Let us have a question. Suppose we want to test that the proportion of students who passed midterm is more than 80%. To test this hypothesis, a sample of 100 students revealed that the sample proportion of passing students is 90%, let us say. Test the relevant hypothesis using alpha to be, let us say 1%, let us say 10%, okay, 1%, using alpha 1%. So first thing we want to make is H naught H1. So read the statement. What are we supposed to test here? Test the hypothesis that the proportion of students who passed is more than 80%. So you are supposed to test that P is more than 0.8. That's the claim. Write the opposite. P is less than equal to 0.8. The one that contains equal sign becomes H naught. The one that does not contain equal sign becomes the H1. Once you are done creating H naught H1, write the sampled information. Your N is 100. Your P hat is 0.9. The sample proportion is 0.9. Now put them into the test statistic and get the value of Z. Z will be P hat minus P naught over P naught into 1 minus P naught over N whole square root. So it will be 0.9 minus 0.8 over 0.8 into 1 minus 0.8 divided by 100. That will give me what?
Two point five.
2.5.
Yes, 2.5.
2.5. So let us try and use the rejection region approach. You will reject H naught if Z naught, what is the side? It's greater than, so rejection region will be greater than if Z naught is more than Z alpha, where Z alpha Z, let us say 0.01, we are using 1% level of significance. Z alpha, which is 1%, that is equal to what? We'll follow the same procedure. We'll convert it to 1 minus alpha and look for 0.99 in the Z table. And you look for 0.99 in the Z table. When you do look for 0.99 in the Z table, you will find that you will not find 0.99 exactly. Yeah, it is there. It is there. It's very close. 0.9901 is there. So the critical value is 2.33. 2.33. So I get this from the table and I get this 2.33. So I'll see my P and my Z naught. I'll say as Z naught is more than 2.33 because 2.5 is more than 2.33. So we reject H naught and conclude that more than 90% students passed, 80%, sorry, 80% students passed. Same thing with the p-value approach. If I want to find the p-value of the same thing, it will be p-value, that's probability of Z more than 2.5. Probability of Z more than 2.5 will be 1 minus probability of Z less than 2.5. So we'll go to the Z table and look for probability of Z less than 2.5. So the probability of Z less than 2.5, we'll have it from the Z table and I will highlight it. It is 0.9938. You can see it on the screen. I highlighted with the green color. Z less than 2.50 is 0.9938. So this is going to be equal to 1 minus 0.9938, which is 0. What is it? 0.0062. So you'll see as the p-value is less than alpha, is less than 0.01, so we reject H naught and conclude the same. You reject H naught and you conclude the same. This is the end of your chapter 9. These are the 3 topics in chapter 9. Testing the population mean when sigma is known, you use z-test. Testing the population mean when sigma is unknown, you use the t-test. And testing the proportion, you again use z-test. Now, if you have any question from today's class, in the next class, I will start chapter 11 tomorrow. So it's very important. Next class is very important, as was this class. So in the next class, I will start chapter 11 and I will try to cover most part of chapter 11. Saud Usman. If you don't have a question, by the way, you can leave at this point.
Doctor, I want to ask you about the midterm grades, when it will be published. And what's the
class
average?
we have been talking about midterm grades. Average is more than 12, less than 11, more than 11, 80% passed, 90% passed. So whole class we were talking about the midterm exam.
And what about the grades? When it will be
Grades
published?
I will upload shortly. I have the grades. I will upload. Maybe next few minutes I will upload.
Thank you.
Yeah, actually I graded last night. I graded, so the grades are with me.
Yes, and what do you see it as great